In this video, we're going to take a look at the accuracy of the Artec Space Spider once again. And the real test that we wanted to do is a linear accuracy test with the system using a ball bar. So because of the way that the Artec Space Spider scans, and with it being a handheld scanning system, the accuracy of a frame-to-frame alignment across a given area becomes a pretty big concern when you're looking at linear accuracy with the system. Because there's no watertight model, we're not actually referencing our object in every different direction. We're just looking at it through one linear direction. We wanted to go in and do a GR&R study to analyze how accurate and repeatable we can make these values. So in doing this, there's a couple things that we set up. First off, we're not just using the part this time. We're actually using some external geometry. Because this is a very flat, simplistic part, we went ahead and added some 40 grit sandpaper as our base to add a little bit more geometry to our part. And we also used a Sharpie on a couple of different taped out areas to add a little bit more texture for our registration process. This test was done with 3 different people scanning the part 2 different times, just like in the previous test, and all of the values that we kept through our scan data processing were kept the same. If you're already an Artec user, then one thing to note is when we did the global registration in this particular application, we took our global registration keyframe ratio value and left that consistently at 0.6. So we're using 60% of our scans that are taken as keyframes, which greatly helps in this sort of scanning process because we want as much of our scan data to be used in that keyframe alignment as possible. Another note is when we scanned, we made sure to slow down our scanning speed to where we had overlapping frames pretty consistently through about a half-inch spacing or less from one frame to the next to ensure that we had plenty of geometry to do all of our alignments. Once that's been done, we go ahead and simply create a couple of spheres using Artec Studio 15 and analyze the center point to center point distance of those spheres and put those into a spreadsheet. So if we look at that spreadsheet, there's a couple interesting things that we can analyze. First, if we look at our standard deviation is roughly 2 thousandths of an inch, 2.3 thousandths of an inch to be specific, across all of these scan files, with a max deviation from the nominal value of our ball bar of 3.5 thousandths of an inch, as written out on the spreadsheet. However, there's one other thing that we need to take into consideration when we're doing this analysis. Because we did it across multiple people and varying times over the course of a couple of days, the thermal expansion of the part that we're actually analyzing needed to be considered. With the temperature fluctuations that we have in this particular office, as well as the material that the ball bar is made out of, that comes out to about 1.5 thousandths of an inch of total thermal expansion that needed to be accounted for in this test. When we look at that and bring that into the mix, we can see that the max deviation that we're getting from the Space Spider is actually right at 2 thousandths of an inch across the entire 2-foot length of this ball bar. So 2 thousandths of an inch across 2 feet when you're scanning in a linear fashion, not using as much geometry as possible, but just limiting it to that one particular linear scanning process, shows us that if we set up our part correctly and we make sure that we have enough geometry to create an accurate alignment across our part, we can get a very accurate scan file out of the Artec Space Spider. So thank you very much for taking a look at this video. And if you have any other questions regarding the accuracy of Artec products, or any questions related to 3D scanning, feel free to let us know.